Welcome back, the people from online. So this is the example of how a simple experiment might look. And now you know that men's and kids are um, kind of large also categories in Vinted, and yeah, the gaming version was scaled. So now I will talk a bit about framework of experimentation. So everything starts with a problem. So we know what we want to achieve. Uh, Next, we do some initial analysis on the problem to get more context and to get some ideas. What is the root of the problem? How might we address it? Then we form a hypothesis. Hypothesis is something like in the previous example, if we make access to men's and kids categories more obvious, then user engagement might increase or listings in those categories might increase. So that was the example of hypothesis. After that, we work on solution and experiment design. So in our company and like many other tech companies, we have a cross-functional teams, a bunch of them, and they work independently, like autonomously, and they can design. So they have a designer, they have an analyst, and a bunch of engineers and product owner, and they develop the idea and implementation of the experiment by themselves. So yeah, next is the implementation. So that's the engineering taking the lead here. Afterwards, we launch an experiment. So it's a bit of a resting period, but of course you are working on maybe other things, not just waiting. Hold on. And then afterwards comes time to do data analysis and see how our experiment performed. So that's mostly led by data person in the team. And finally, we come to the decision of the next steps. So we evaluate if the test was success. Do we need to do another iteration? So basically, we might get back to the problem. If we didn't address it in any way, we might, come back and do it again. So now I will go into examples. So I selected 3 cases. So the first case was of the experiment, which was launched by my team. So the idea was quite simple. We wanted to test how delay in page response affects business metrics. So that is latency test. The idea is that we have some target metrics for our engineering department. So like, average page load time should be like this, and other tiers that we want to keep consistent. And we wanted to see if we can set more ambitious values, maybe there will be some significant business gains, or maybe we can relax and not invest that much in our infrastructure because it doesn't affect business. But as you know, other tech companies report significant business gains from improving page response time. So initial analysis showed that other tech companies have gains, so maybe we also have them. Maybe we're not that special. So we formed the hypothesis. If we delay page response time for some users, their engagement would decline and some business metrics would also suffer. This is a bit weird hypothesis, right? I mean, why should you ruin experience for part of the users, but the limitation is that ruining is much simpler than improving it for the part of the users. So that's how we decided to address it. And it was based on the assumption that if we see a decline for some delay, then we would probably see a very similar improvement if we improve the page load time. So yeah, that sounds like a very legit idea, nice test. And then we got to test design and implementation part. I must share that at that time, Vinted was in a very large growth period. We were hiring a lot of people, and I was covering 2 roles at the same time. But we had an agreement with the team that, test idea is very simple. Probably we don't need your direct involvement. I mean, it's very engineering-driven test. So the team says, we will ask for your input only when we need it. We shook our hands on it and said, okay, let's roll. So after some time, team came and said, okay, we need to determine what kind of delay we should do, what kind of values should we select for delay. I said, okay, yeah, that's simple enough. We just look at distribution, what are now of the page load times, and we selected some reasonable values. Okay, we're good to go. Test was launched. After some time, it was my turn to do the experiment analysis. So, okay, let's dig in. What I noticed is that not all traffic events were available for a test variation. So basically the users who had normal experience, we had all the necessary trafficking, but for the ones with modification, not everything was in place. So that was weird. I went to the team and said, okay, can you explain why is that so? Turns out that the team decided to save some time and chose a bit different search suggestion engine than the control because it was easier to implement with the delay. So I was annoyed after hearing that. So it turns out that the test had 2 changes, and any difference that we observed might not because of the latency, but maybe because of a different search suggestion engine. And when they said, we assumed that it didn't matter, but when we looked at how the prompts behave upon starting typing something, they were really different. So we couldn't assume that it didn't matter. So we spent a bit of the time discussing if we can use any data from that test. Maybe we can still find some value. So yeah, the conclusion was that the test is invalid. We cannot make any conclusions from it. And basically all the time and effort was wasted with that. So yeah, let's go through learnings. So first thing is the obvious one. Only test one thing at a time, and that thing should be stated in your hypothesis. You should not add any changes that are not stated in your hypothesis. Also, don't make assumptions without informing your team. So the assumption that team made was those 2 search suggestions engines don't really differ in terms of user experience. So that was also a mishap in communication. So yeah, we should communicate more. Even if you want to save time, your analyst who is maybe swamped with doing something else, this is important. Let's keep everyone involved. if you make any shortcuts, they might introduce test flaws and potentially invalidate the whole test. So you were trying to save some time, but it might result in having a bunch of time of the whole team wasted. And the last one is maybe not specific to experiments, it's very general. You cannot do a quality job if you are assigned to it part-time. I think there was one saying, not sure the author of that, but want the project to fail, assign it to a part-time project. So basically, this is also like important learning from, you cannot do really good job if you're trying to be in two places at the same time. Now I will talk about second case.
Can I ask a question?
Yeah.
So what was the outcome? Like, did it change the business metrics after all? Like, you changed two things. Did it affect anything or not?
There was some decline, but we still couldn't figure, was it because of the...
Yeah, okay. Thanks.
Okay, so the second case, I named it the feature adoption push. So it was not a single experiment, actually like a group of experiments who could fall into the same theme. And it starts like this. We notice, oh, this feature is associated with high user engagement. This looks promising. And there are a bunch of features like that. So to name a few examples, for example, user might save their payment card for later, and she will have easier checkout in the future. And users who do that buy more. Another thing, they might set some preferences, like in Lithuania we call it nustatymai, for more convenient content discovery. So for example, they might set up their preferred brands or sizes. The third one, we know that the power buyers follow more listers and power sellers have more followers. So it's also quite clear relationship with that. And to add a bit one like funny one, the buyers who buy most, they also see more ads. So it's a bit counterintuitive, right? But when you think about it, not really. I mean, they just browse through a lot of content, so they obviously stumble upon ads too. So when you find like this insight, you might be tempted, okay, let's push this feature to casual users. So the example of hypothesis would be, if we push users to follow other listers, they might buy more items. So the design of the test would look like you have onboarding on the platform, and then a screen pops up and says, follow some new users, here are some suggestions. But I'm just entering the app, maybe I don't know anything yet. So the idea is don't confuse correlation with causation, because those are like really, even I have seen even the really smart people confuse that. And features which improve user experience for power users, they're not likely to increase engagement for casual users. So in the example of this dude in the slides, so he's having a cool funny glasses, and you might see, oh, he has glasses and he's rocking out, having a good time. So if we hand these glasses to everyone, then everyone will start partying. Yeah, probably that's not how it works. He probably was in the mood to party, and that's why he chose those glasses. So the takeaway is to be aware and critical on hypotheses based only on correlation. My team hasn't been designed in those too much. There were like a few of them maybes, but I have been involved in some postmortems which were like obvious confusion cases of correlation and causation. So you can also waste a bit of the time when designing those kinds of tests. Okay, third case. You launched the test and your test did not have any effect. So you can see like this disappointment in the player. And is in the role of a data person when you come after the test to do analysis. You might check some basic stats and see, okay, no improvement. Okay, maybe there was something wrong with the test, you know, like first stage is denial. Maybe we didn't turn the feature switch for the test, or maybe there was some interference, like maybe another team launched the test which interfered with this, or maybe some marketing campaign. You know, something must have happened. Maybe we can do some segmentation. Maybe it worked, but only on part of users. And when we look at all users, we don't see that effect yet. You know, let's not lose hope. There might be some value in this. You turn to teammates for some suggestions. Okay, I checked this, and that. I don't see any difference. Maybe you have many ideas what else to check, and oh boy, the team delivers. They deliver a bunch of things for you to check. And you spend some time, because you know, you were part of the team, that you were part of the process which launched the test. You are part of the team, and everyone is looking at you very hopeful. You want to find some value in the test. So yeah, you start digging, you know, maybe we'll find something. So in usual case, you don't find anything. But team is, you know, they have a lot of ideas. They are also quite committed to the test. They don't want to see their time wasted. So yeah, this process might consume a lot of time. And this time could be better allocated to testing new ideas instead of, you know, digging and being in denial and looking for some rudimental value in the test. So my takeaway from this case would be, do some tests, but if you are starting to feel that you're doing discovery for additional iterations of the test, plan it in the context of other initiatives. Don't let other ideas suffer just because of your sunken costs. And be very deliberate on how much time you want to allocate. So actually, failure is part of learning. If you stumbled upon a test which is not successful, it's actually quite the norm. So if we look at, let's say, average soccer team in Premier League football, oh yeah, we're in Europe, I can see football. So their shot to goal conversion is 10%. So out of 10 attempts to score, only one out of 10, one only would be successful. And it is a quite similar situation in very advanced tech companies. So I have found some stats in a KDD paper from other companies, so you can see that the success rate varies from 8 to 15% in most cases. Microsoft is a bit more standing out with 33% success rate, but still, failure is more usual case than the success, and it's fine. You can learn a lot from learnings, from failures, and you can also share your learnings. That's the very important part. You can share like I'm doing right now, and maybe some people will not stumble on the same mistakes as other teams do, and their next test would be better. Okay, so let's summarize. I presented to you the workflow of the A/B test, and we found some cases where the mishap happens in the design part of the solution. I also presented the case when hypothesis might be formed not correctly. And yeah, the last part, the third case, was about not really timing the analysis and committing to potentially that case. And yeah, I just put all the learnings here from all three cases. Yeah, maybe someone has any questions here. So I probably don't want to read them all, but yeah. But I can summarize really quickly. So communication with the team, very important. Being involved and committed to the process. Also asking input from other teammates and giving them full context. Be very critical when forming hypotheses. And yeah, being very conscious of your time. I don't know, how am I doing with time? I think I'm good. So yeah, that's it from me. If you want to learn more about fails, there is this author, Kohavi. He has some publications about it. I think there was also a video on YouTube from 2020, the year of remote conferences. So you can check it out if you want to hear more. Okay, so do we have time for questions?
Sure. Could you provide some examples which were working, like 3 examples which were most useful, and like 3 examples which were most surprising when you were expecting that something will work? They have found that it doesn't work.
Agnė, could you please repeat the question?
So the question was, I was asked to share 3 cases of success and 3 surprising cases where we were surprised by the results. So 3 is quite a large number. So the first slide which I shared about making more prominent navigation, and that was really successful, and we were it was more successful than we expected it to be. So yeah, turns out men's category and kids category do have potential larger than we assumed before. And in case of unexpected tests, I think one was, the first example which comes to my mind was remove, which was like a while ago, and it didn't have any, even though it was used by users after removing it, they just didn't use it, but their engagement was the same, their buying activity was the same. So basically, we improved UX with that and did not harm business, and yeah, removed outdated feature. Okay, and yeah.
thanks for the presentation. Do you have any rules on how you are formulating hypotheses and maybe communicating out to the rest of your team?
Okay, so the question was, do we have any rules on how to formulate hypotheses and communicating them? So what I usually suggest, and to all teams, is to formulate hypotheses into the shape of if something, something, then something, something. So for example, if we, I don't know, add this feature, then this and this metric would increase because users would be able to find content quicker, or would be find more relevant content. Yeah, that was the example. So yeah, the hypothesis should be short and concise. The best would be like one sentence. And quite scientific form, I would say. I think research scientists also do use this.
Okay, so my question is, what sort of changes are most difficult to measure and track? So maybe
yeah, so the question was, what changes are most difficult to measure and track? Maybe in some cases there are user experience improvements. So, for example, a designer comes up with something really nice and pretty, and you think, okay, this should definitely improve our business measures, but turns out that in most cases, users just do some things quicker, but not more. So this is quite difficult to measure, because usually it's hard to think of the metrics about how user experience might affect business metrics. Or, in some cases, there are also legal obligations, so things we have to do. And then, some people would say, what's the point in measuring? We have to do it anyway, because that's, we are required by the law. So, yeah, those also are quite difficult discussions, like, should we measure? How do we measure it? Yeah, things like that.
So if you share the stats on how popular, well-known brands perform in terms of win rate, and what's the win rate in Vinted? Yeah, if you can share this number.
So the question was about best performing brands at Vinted?
No, just worldwide, best performing
Worldwide.
brands, what's the win rate? So like 10%, 15%, but what's the win rate in Vinted, of total win rate of all
In experiments, you mean? We actually haven't measured which part of our experiments is successful, and I think it's mostly because some teams don't share their fails. Wins, we do know how many wins we have because they are communicated very loudly, but yeah, we are still working on encouraging teams to share some more fails. So we don't have the exact number.
Question. So, do you know how many usage sessions on average does it take for a A/B test to be deemed statistically significant?
The question was how many sessions does users have to perform so that we would have enough data indications to call the success. So in our usual case, we actually don't count the sessions, we count the distinct users, because when we do statistical comparison, we have to make assumption that observations are independent of one another, and the same user from different sessions, it is of course, their sessions are highly dependent. So we count the number of users, not the sessions, but right now we have quite high activity, so usually it is not a problem to gather enough users unless you are testing something which is like really specific.
But do you know what number that is? Of how many users?
So, yeah, I have, now I'm remembering things which I did like 3 years ago. There were cases where maybe we need 60,000 users, maybe, yeah, about, like in that range, like a couple of, in tens of thousands or maybe hundreds of thousands. It depends on the conversion rate you're measuring and how large effect you anticipate.
What's the share of experiments that focus on acquisition versus like retention?
Question was about share of experiments on acquisition and retention. So retention is very tricky to measure because retention is lagging indicator. So something you did might affect user decision to come back in, I don't know, half a year maybe, because some users do shop only twice a year, when their kids grow out of their clothes, so they eat twice a year. So we don't have tests to address specifically retention. We do use user engagement as proxy to retention, but we are still, building this methodology to do that. It's not yet bulletproof, but we are not the only ones. The whole industry is doing the same things. I think we in Vinted are quite lucky. I think like Airbnb have much rarer usage than we, so we can measure retention afterwards, at least after some time. But yeah. Okay. Any more questions? Yeah.
How does one determine if a hypothesis is correlation-based or causation-based?
The question was, how do we determine if a hypothesis is correlation or causation-based? So it is a good question. It's not always obvious to distinguish these two cases, but that's why we encourage to do some user research. So our designers are also quite important in building this hypothesis. But of course, we usually overestimate the potential that some feature might bring. But we can learn from experience. We are quite now good at recognizing obvious confusion cases of correlation versus causations, but yeah, there are some cases which are not clear. So yeah, we might make an A/B test and find out if it was just a correlation or it was a causal relationship. I love that you guys are very active. I don't know if I should stop with the questions now.
I think it's time to say something.
Okay. But yeah, thanks for your attention. I really appreciate it.
What do I click? Our presentation is here. Screen. Should be good, right? Yeah. O kaip po to į slido persijungs? Okay, well, we'll try. Okay.
Hey everyone, good evening, I'm Jeff. So let's start. My presentation, by the way, I was finishing last night right before I arrived here, so it might be a bit all over the place, so I apologize for that, but hopefully I'll keep you entertained. Following up on what Agnė presented about experimentation, brief recap. What is an experiment? Say you're on a Microsoft and you want to run a test on your search engine, Bing. You have the control. where you have some text at the bottom of the search result, and in the treatment group, you just move some of that text into the link itself, and then you measure the difference. They actually did that test at Microsoft, and they found out that this simple change led to 12% revenue increase and 100 million per year, to be specific. So that's the basics of experimentation, but the topic of experimentation itself can be way more, I guess, complicated than that. There are loads of different types of experiments. There are loads of different techniques to analyze experiments. There can be adaptive experiments, fixed experiments, all sorts of experiments, you name it. And it's very cool that you're all asking questions because this topic is fascinating. So what does it mean in experimentation? It means that, as you saw, and just the final question was about that, how to distinguish correlation from causation. That means that assigning the value to the idea is very hard because of that. Small changes can have big impact, and therefore you should have a lot of experiments all the time, and the overhead of running these experiments for the product teams should be as low as possible. That's why people go to an extent of developing experimentation platform. But the topic that I'm going to talk about today is machine learning teams or experimentation teams. And I don't like the word machine learning. I prefer data science. Just to throw in some, arguments out there. We can argue about this in the discussion section. Or why you should learn regression. If you would like what I'm talking about, feel free to connect on LinkedIn with me or talk afterwards. So a bit who I am. Those who don't know me, my background is all over the place. I did some MSc in applied mathematics and worked in astronomy, then did PhD in medical imaging, and there I worked primarily in computer vision. I didn't finish my PhD actually today. I'm officially dropout from the PhD program. And then I worked as a senior statistical scientist, a bit in climate science and remote sensing, and then machine learning at Vinted, and then experimentation at Vinted. And this is our team already a year ago. We are far larger than right now. And today here, actually, it's me, Agnė, and Giedrius in the room, who are all three of us are from Vinted experimentation team. So we are the scientists on the team, so feel free to chat with us about anything that you find interesting about experimentation. Right. So it's an AI kind of meetup, and there are a lot of different AI models out there, machine learning models out there. And we as data scientists often are excited to, oh, there's a new transformer coming out, and we want to just go ahead and apply that transformer to whatever new problem we face, or there is a XGBoost version, whatever, that you're interested in trying out, and you want to straight away apply that to the problem. There are so many powerful tools, you can't even pick which one you would want to use. I don't know if people are getting any references. This is a transformer, and this is the chinchilla paper from DeepMind. But anyway, so a product manager comes to you. Oh, yeah, and it's a hammer. You could hammer pretty much any problem with whatever model whatever problem you might be facing. And so the next problem that you're facing, the product manager comes to you and they say, well, we want to do some sentiment analysis. We've collected some reviews. And can you do some magic with transformer or chinchilla or whatever model you have and do some sentiment analysis? So therefore, Slido time. What do I click? Get your phones out. Yeah, so there is the Slido. You can scan the QR code and there will be questions. Now remember, you're a data scientist and you're faced with a sentiment analysis problem. And the question is going to be, I'm going to launch it in a second. Hopefully it will work, fingers crossed. All right, I see most of the people have connected. Let's launch it. How would you start solving a sentiment analysis problem? Type your answers, as many as you want. For those who don't know what sentiment analysis problem is you have a bunch of text, let's say reviews from different people, and you want to classify the sentiment of these reviews. Do people write that the product is bad in the review, or do people write that the product is good in the review? And you build a machine learning model to say if that review has good sentiment or bad sentiment. Ah, great, excellent. I love the use if else statement. Excellent. Research. NLP. Use Google NLP, BERT. I should have included BERT on that image before. Google Translate. Call Jeff. No, don't call me. Actually, I've never worked on a sentiment analysis problem. Ask for context. Throw ML to the wall. Does it mean like throwing ML at the problem or just like throwing ML to the wall? Use Hugging Face pipeline. I'm really curious, what is research? What do people mean by research? Could someone clarify what do they mean by research? Sorry?
I didn't wrote that, but my guess would be by Googling without.
Googling, okay. All right. EDA, excellent answers. Check examples on internet. Right, and how do I switch now back? Can I just do Command Tab? All right. Now I need to make full screen view. Yeah. Okay, so plenty of answers, anything from EDA to Googling to calling me. Don't rely on me too much for this problem. Oh, why is it automatically switching? Now you got all the spoilers. Yeah, so actually, the first thing you would want to do is actually ask a question why you want to do that. If this is, for example, to collect some reviews on your product, probably the best solution that will reach the highest accuracy instead of any algorithm will be to just ask your members or users what is it that they think about the product that they are reviewing. And in fact, you see all the major platforms do that. So this is an example from booking.com, and example itself I am stealing from Lucas Vermeer from who was at Booking before. I thought it's such a lovely example to show that actually a good data scientist probably will be the first one to tell where you don't need a machine learning model. And that really is not emphasized enough. And you really get to this point by asking a question back to your stakeholders. Is it really the model that they want to build? What is it that they are trying to achieve? And, well, since it's a presentation, we have to have a quote here. Judge a person by their question rather than by their answers. This is relating that you should start with a question. All right, but say that you did clarify that you did need a model, and you choose that model to be a transformer. Everyone knows what a transformer is?
Nobody knows.
All right, a transformer is a neural network. The joke here is that there is a specific type of neural network model that is referred to as transformers, and here we are doing the reference to the neural networks transformers. And you decided that you do want to build transformer for whatever problem that you're trying to solve. I actually don't remember what is the next slide, so I'll be surprised myself. Yeah, actually the transformer that you're developing will likely be part of a way more complicated system. Just like the actual electrical transformer that is part of an electrical grid, the machine learning model that you will develop and deploy in production will be part of a way larger product where different aspects and features interact with one another and might lead to different results than you expect from your model. So for example, again, Microsoft Bing. This is an example of a causal DAG, or let's say just a DAG, direct acyclic graph, or just a bunch of squares with arrows that shows how different parts of their product influence one another, or at least what they think. So this is a search engine, or specifically auction for ads as a result of user search. So there is some user intent that produces the query. This is what you type in the search engine. Then a machine learning model produces some scores for the query, given the queries and the ads. And these scores essentially say how likely are you to, given what you're searching for, how likely you are to click on a specific ad. And then that produces the slate. This is the results that you see on the search. And the model also produces the prices at which the auction should happen such that Microsoft makes revenue of the ads. And then user intent is that they will either click or not click on the ad, and that may or may not lead to the revenue. So you can see it's exactly the same thing, these two things, right? No? Okay. didn't make that connection well enough. But what we are doing is that we think we should develop a transformer neural network that will take in the query, it will take the properties of the ads, and then it will predict the scores, how likely are people to click on a specific ads. And the better we predict ads will people click on, the more the more money we'll make. Is that clear at this point? Excellent. I had another thing. Yeah, so then another opportunity for Slido. Then the next question. So let's stop this. And here's the question. Please submit your answers. I actually have a secret research agenda, that's why I'm collecting these answers. You're all helping me out. What is that? What is UW? Check medium for solution. Use a hammer. That's nice.
Jeff, is there a limit on the number of characters?
I don't know actually.
Or is my phone just broken?
Someone who's really spamming, call Jeff. Start with a linear regression, install CUDA drivers. All right, well, enough of that. Make a prototype. Business metrics. Yes, business metrics. That's the winner of the evening. I'm talking about business metrics. So back to this example, we need to be very clear about what is it that our model is trying to achieve. Very frequently, what people will start with is actually not the business metrics, is that they will recognize that it is either a regression problem or a classification problem, then pick a mean squared error or binary cross entropy loss, and they will go with that, and then we'll hope that it will lead to improvement of whatever metrics that they care for. But in fact, the first thing you should start with is actually figuring out what business metrics that you're trying to target by making a change in this complex system. Like in this case, it is, for example, revenue. And why is that important? Because you have to select models when you're doing the model development. That will lead, hopefully, to improvement in your business metrics. And this slide is actually from a paper from Booking.com at KDD. 100 successful machine learning models, 6 lessons learned at Booking.com. And what you see here is the relative difference in performance of a machine learning model offline. So this is, let's say you are developing a classification model that predicts 0 or 1 if a user will click on a particular ad, as an example before. And you have some offline performance score. So let's say accuracy, F1 score or whatever. So you use that to select, to do feature engineering, to select the features that you're going to use, to select the type of transformer that you're going to use, do all sorts of hyperparameter tuning. Then what you see on the y-axis is relative difference in conversion rate. So this is the actual business metric that they care for. And what usually you would expect to see is that there will be a linear relationship, so that as you increase the performance of your metric, that increases the performance of your metric, which in fact is not the case because your machine learning model is part of a complex system. And multiple models could probably explain the data you already have. And determining which one is closer to the truth requires the correct effort to collect new data. But actually, before we go into the next slide, we'll go back to Slido because there is one last question. There it is. This is really now a research agenda from me. This is not related to the presentation. Great search, nice. Great search. Okay. Cross-validation. Anything else? Business people. Keras tuner. People still use Keras? Ensemble model. Brute force. Dali. History replay with regrets. That is deep. History replay with explainability. Okay, that is a valuable one. All right. Oh, A/B test, yes. So naturally, the answer that we're going towards, because we're talking about experimentation, is an A/B test. And then just to repeat, multiple models can explain the data that we already have. We could fit different models, and they will all be good on offline metric that we're interested in, but they might perform completely differently on the online metric that we care for. And that requires us to run an A/B test and collect new data. What do we mean by that? That multiple models can explain the same data. So here we have a kind of intuitive example with code. On the top, we have a Gaussian distributed random variable. It's a multivariate Gaussian. You see the actual scatter plot, and you see the marginal distributions on the x and y axis. And I used three absolutely different source codes to generate these distributions, and they lead to different underlying causal structure. And you'll see in a second why is that important. But the key thing here is that it's absolutely different pieces of code that generate exactly the same looking data. If I actually try to make an intervention, and us introducing a new machine learning model into product is making that intervention, and we're trying to get the intuition behind what that means. If we do make an intervention, but for example, setting a variable x to free at every line of code, we will see that the marginal distributions actually start to differ between each of these three different data generating processes. So when I intervene in every line on three of these different pieces of code by writing x equals 3, actually the average only ends up the same for green and yellow pieces of code, but for blue one, the average ends up being different. And that is what we mean by saying that for the data that we have, we may have different underlying true data models that generate our data. And that is the reason why we have to do A/B testing, and we can't rely just on offline metrics. If we want to be really specific, we can plot these distributions under this is just conditioning for simple statistical operation, where we try to estimate the density of our y given x equals 3. And the one on the top is where we actually do the intervention, where we set x specifically equal to 3. And you can see they're different. That is why we cannot rely simply on correlation or on offline metric performance. And we actually have to do the A/B test to determine what leads to the increase of the business metrics. So if we connect that to the example from Microsoft, so now instead of changing the text, we have two versions of, we have the previous machine learning model in control group that was doing the prediction of scores of how likely people are to click on the ads. And in the treatment group, we put the transformer that runs and does the prediction. And we're very happy because we see over 9,000 increase in revenue. But then the problem often is that it's not just one metric that you care for when you are developing your machine learning models. And here it's going to get really abstract now. These are the actual slides I was preparing right before. Now, why you need to learn linear regression? The way you analyze these tests is one, you can do a t-test, or you can do a linear regression, where your metric value for a particular user is the y here. the intercept is alpha, the beta 1 is your treatment effect, and the t is the indicator variable if your user is part of the control group, or if it's 1 if they are part of the treatment group. And the hypothesis you're testing is there actually any treatment effect. So if there is no treatment effect, the beta 1 will be 0, and if there is treatment effect, it will be some value. Could be negative, could be positive. So just to get some intuition for your linear regressions. So beta 1, in this case, it will be the intercept, the alpha. So this is the mean performance when we don't introduce any of the treatments. So we don't introduce the new model or any of the features tests that we test, for example, from the example that Agnė gave before. The beta 1 that we estimate from our linear regression is actually the slope or the difference between the two groups. So it is very much the same as t-test. So that's the intuition. And that's why you should learn your linear regression, because there are a lot more cool things that you can do by interpreting it as a linear regression. I actually learned it recently myself. There is such thing called Cupid or variance reduction. You could all just chuck into one linear regression all of the different experiments that you're doing at the same time and estimate the treatment effect simultaneously for them while increasing your precision. This is just fascinating. So just to make it visual, your y is it purchase or not, for example, 0, 1. Here for this particular user, it's 1 because they're in test 1 in treatment group, and in test 2, they're in control group, so therefore it's 0 there. And then you fit that linear regression and you get your coefficient. And that's how you interpret the tests. But in reality, you often will have multiple metrics that you care for. It will be not just optimizing revenue, but also increasing retention. So for example, if you start just serving very clickbait ads, sure, people might be clicking on them in the short term, but in the long term, people will just start getting annoyed, and you might see people churning from your platform, and therefore, that in the long term, that is not good for the business. So you have to account for these things as well. And you might have other metrics that your product team also cares for. So the question is, how do you trade off these different metrics? And there are no good answers for it. But there is a way to think about it. But I think it might be a bit too much for this evening, and therefore I might stop here, unless we should continue. All right, we can visualize it. So we have metric 1 here, the values for metric 1. We have the values for metric 2 on the y-axis, and the gray dots are different tests or experiments that we run. And what these dots mean is how much lift we achieved with different tests on 2 different metrics, right? Experiment test, I'm using it interchangeably. So we've collected some experiments, and we see that there is a range of experiments that is really improving the performance across both metrics. So this is called Pareto frontier in the optimization literature. And this is essentially the best point, the best edge of the whole data that we have that achieves the highest performance for the metrics that we care for. And you can imagine here we draw it for 2 dimensions, but you can start drawing it for multiple dimensions or more. And then your target becomes to continue doing experiments. And how do you know that you keep improving is that you do a few more experiments and you see if your new Pareto frontier is actually has more area under the curve compared to the previous Pareto. So all we're doing is that we're comparing how much area does the red line covering compared to the pink line. And that's just an abstract way to think about multiple metrics. And that's it. Yes? Any questions?
So there's probably a lot of assumptions that you're making here, right? So the tests have to be really independent, for example. Right?
Mm-hmm.
I mean, is there anything interesting there?
I don't know. There probably is. The reason I'm fascinated with this topic is that there are quite a few publications from Meta's core data science team. Ethan Bakshi and Sam Dalton did quite a bit of research, and they actually have this stuff running in production where you fit Gaussian process to describe the Pareto frontier, and then you use that Gaussian process to explore what next experiment you should run. So for example, if your recommendation system, and they push it a bit forward more, where they say, okay, well, so what, we know the Pareto frontier. The product manager still has to make a decision which metric, which trade-off between metric 1 and metric 2 they prefer, and eliciting that trade-off is really hard, because your stakeholders are not quantitative, your stakeholders might not be very clear about what trade-off do we care for, so they go ahead and they just learn by preference learning from their stakeholders what option on the Pareto front they prefer. And this is just fascinating, mind-blowing, I really like it. Yes?
Could you go back to the slide that the experiments and the correlation between offline and online metric?
Yep.
So I was curious, why would anyone run an A/B test there? They have like worse machine learning model.
So actually they give example in the paper where at some point the recommender became so good that it became creepy. Where Booking.com the recommender would recognize if you're making, for example, you're flying to, I don't know, Italy, and then you're likely making a connection to Spain, but you didn't insert that into Booking.com, you just made a booking for, I don't know, for an overnight stay in Italy, they will straight away start recommending you for a stay in Spain, and they will be really persistent about it. And they actually inserted in the paper comments that people write where people kind of say, okay, why is it so creepy? How do they know where I'm traveling? Pizza time or whatever, food and drinks time?
Any last questions?
All right, thank you. Woo.
So just to wrap it up, really great job, speakers. Thank you a lot. Thank you all for being here. And as Agnė very correctly said, we have an after party in San Diego Pub. So if you want to talk more, let's meet there. And thank you all for coming. So I guess 1 second and broadcast.